Hello kids, welcome. Let's start chapter number 4, Earth's structure of geography. Now, today we have a lot of knowledge about the interior of the earth. Okay, now all this knowledge which we have about the interior of the earth, let me tell you, that knowledge we have not acquired by doing excavation or by doing some exploration. No. All our knowledge about Earth's interior is based on what? So, first, our knowledge about Earth's interior is based on material which is thrown up at the time of volcanic eruption. So when volcanic eruption takes place, lot of molten material is thrown up, volcanic material is thrown up. Our scientists, our geologists have done study of those material, and that is how they have obtained some information about Earth's interior. Second, our knowledge about Earth's interior is from the study of seismic waves. Seismic waves, which are also called as earthquake waves. So, seismic waves also help us to know about Earth's interior. So, there is primary seismic waves and there is secondary seismic waves. Now, primary seismic waves can pass through solid, liquid, gas, all three of them. But if you see secondary seismic waves cannot pass through liquid. So there is an instrument, there is a proper scientific instrument called as seismograph. With the help of that scientific instrument, we are able to get information about the movement, the passage of seismic waves. That also gives us information about the Earth's interior. Third, our knowledge about Earth's interior is based on study of meteorites. Now, scientists have done study of meteorites, and after doing research on meteorites, they concluded that meteorites are made up of the chemical composition. The composition of the meteorite is same as the rocks which are found in the Earth's interior. Their composition and the composition of the materials thrown of the meteorite is same. It is same. So, in fact, it is said that Earth is constituted of the same material of what meteorites are made up of. And also, our knowledge about Earth's interior is based on theory of origin. So all our knowledge about Earth's interior is from these four things. First is with the help of the study of the material thrown up at the time of volcanic eruption. You know very well, when volcanic eruption takes place, what material is thrown up that comes out from deep magma chamber. So in short, we are getting to know about what is deep inside the earth, what is it made up of. Second, our knowledge is about the study of seismic waves, in which primary seismic waves can pass through solid, liquid, gas. But secondary seismic waves cannot pass through liquid, and the seismic waves can be recorded and studied with the help of a proper scientific instrument called a seismograph. Then our knowledge is also based on the study of meteorite. Earth is constituted of the same material what meteorites are made up of. And also our knowledge is based on the theory of the origin of the earth. Now in this chapter we are going to talk about the three layers which are made up of, which our earth is made up of. But before that, let me tell you one thing. As you go deep inside the earth, the temperature start rising. In fact, it is said that for every the temperature in the Earth's interior start rising. because it is said that Earth's interior is made up of radioactive element. Plus there is large scale movement happening under the surface of the Earth that generates a lot of heat under the surface of the Earth. So we are going to talk about the interior of Earth. So the innermost layer we are going to talk about. So Earth's interior is made up of 3 layers: core, mantle and crust. Core, mantle and crust. First let's start with core. The innermost, densest and inaccessible. Innermost, densest and inaccessible layer is called as core. It is the most inaccessible part. It is the densest part. Okay, it is the densest part in the center of the Earth's interior is called as core. The diameter of the core is 7,000 kilometer. Core is divided into 2 parts: inner core and outer core. Inner core has got temperature of around 6,000 degrees Celsius and outer core has got temperature of around 4,400 degrees Celsius. Now, the diameter of the core is 7,000 kilometer. It is believed that core is made up of iron, that is ferrous, Fe, and nickel, that is Ni. It is said that core is made up of iron and nickel. Iron is Fe and nickel is ferrous. That is why core is called as knife, N-I-F-E. And there is so much of large quantity of iron that it creates magnetic. It is responsible for Earth's magnetism. The Earth's magnetic effect is because of large quantity of iron in the core. And this magnetic field is mainly oriented at North Pole and South Pole. This magnetic field is mainly oriented at North Pole and South Pole. So, core diameter is 7,000 kilometer, made up of 2 parts, inner core and outer core. Inner core temperature is 6,000 degrees Celsius. Outer core temperature is 4,400 degrees Celsius. Ore is made up of nickel and ferrous, so we call it as knife, N-I-F-E. Core has so much of large quantity of iron that it is responsible for Earth's magnetism, and that magnetic field is oriented at North Pole and South Pole. Inner core, in spite of having 6,000 degrees Celsius temperature, it is in solid state, because in the inner core, density and pressure both are very high. Density and pressure are so high that it keeps inner core in solid state. So primary and secondary waves both can pass through it. But outer core is in semi-molten state. That is why secondary seismic waves disappear in the outer core. Secondary seismic waves disappear in outer core. So inner core, I repeat again, in spite of having such a high temperature, it is in solid state because of high density and high pressure. Now after core comes a boundary which is called as core mantle interface. It's a boundary between core and mantle, and this boundary is called as Gutenberg discontinuity. Gutenberg discontinuity. Now we are going to talk about the next layer. We will talk about this boundary afterwards. The next layer called as mantle. The next layer called as mantle. Now, it is said that mantle is the largest part in the Earth's interior. It occupies the maximum part in the Earth's interior. It is a layer which is below crust and above core. It's a layer between crust and core. The thickness of mantle is around 2900 kilometer. After mantle, we have one more boundary between mantle and crust, and that boundary is called as Moho discontinuity. Is called as Moho discontinuity. Now the thickness of the mantle is 2900 kilometer. Mantle is also divided into two parts, upper mantle and lower mantle. So upper mantle start from Moho discontinuity up till 700 kilometer. Now from 700 kilometer till 2900 kilometer is lower mantle. From Moho till 700 is upper mantle. From 700 till 2900 kilometer is lower mantle. Upper mantle temperature is 1000 degrees Celsius. Lower mantle temperature is around 3700 degrees Celsius. Again, lower mantle in spite, of course upper mantle is cooler and less denser as compared to lower mantle. Lower mantle in spite of having such a high temperature is in solid state. Again because of high density and high pressure. Because of high density and high pressure. Now upper mantle, there is a specialty about upper mantle which I want to talk about. In upper mantle between 100 and 410 kilometer, between 100 and 410 kilometer in upper mantle, there is a semi-molten layer, and that semi-molten layer is called as asthenosphere. It is a part of upper mantle between 100 and 410 kilometer. It is a semi-molten layer. It is called as asthenosphere. Now tectonic plates float in this layer. About tectonic plate we are going to study in detail in further chapters. So the specialty of the upper mantle is existence of asthenosphere, which is a part of upper mantle between 100 and 410 kilometer. It is a semi-molten layer. Our tectonic plate float in this layer. Our tectonic plates float in this layer. Mantle occupies around 84% of the Earth's interior. In fact, 11% is core. 11% is core and crust is only 1%. So mantle, two part, upper mantle, lower mantle. Upper mantle is cooler and less denser as compared to lower mantle. Lower mantle temperature 3700 degrees Celsius, upper mantle temperature 1000 degrees Celsius. Thickness 2900 kilometer. Upper mantle start from Moho discontinuity, ends at 700 kilometer. Lower mantle starts from 700, ends at 2900 kilometer. Upper mantle between 400 and 410 kilometer has semi-molten layer called as asthenosphere. The significance of asthenosphere is our tectonic plates float in this layer. Upper mantle is cooler and less denser. Lower mantle, in spite of having high temperature, is in solid state, again because of high density and high pressure. Then we have the last layer, the outermost layer, the least dense layer, the most accessible layer, crust, which is called as crust. Crust is only 1%. It is also called as lithosphere. Crust is also called as lithosphere. It is completely made up of solid rock. Crust is only 1% of the Earth's mass. Now there is a crust below the mountain also. The thickness of crust below the mountain is 60 kilometer. And the thickness of crust below the ocean is 5 to 10 kilometer. Crust is also crust is also divided into two parts. We have oceanic crust and we have continental crust. So continental crust is called as Sial. Continental crust is called as Sial. Oceanic crust is called as Sima. Continental crust is Sial, oceanic crust is Sima. Sial, silica, alumina. Sima, silica, magnesium. Sial is lighter and less denser than Sima. That is why Sial floats over Sima. Sial forms continental crust, Sima forms oceanic crust. Sial will float over Sima. Now, you know what? Crust is very, very thin as compared to the size of the earth. The temperature of the upper part of the oceanic crust is estimated to be around 0 degrees Celsius, and from oceanic crust, as you start going inside, the temperatures start rising. Okay, the pressure and the weight of the rock also start rising. So Sial and Sima are the two part of crust. Upper mantle, lower mantle are the two part of mantle. Inner core and outer core are the two parts of core. So these are the three layers of Earth: crust, mantle and core. Crust, mantle and core. As I said, there are two boundaries. The first boundary is between core and mantle, which is called as Gutenberg discontinuity. Gutenberg discontinuity starts at 2800 km, ends at 2900 km. It is also made up of same large quantity of iron. In fact, primary wave's velocity will decrease in this and secondary wave disappear, suggesting that it is also in semi-molten state. Secondary wave disappear in this, so it is in semi-molten state. What about Moho discontinuity? It is a boundary between mantle and crust. It's a boundary between mantle and crust. It's basically doesn't have its own characteristics. On the lower side, it has characteristics of mantle. On the upper side, it has characteristics of crust. Below the continent, the thickness of Moho discontinuity is 32 km. And below the ocean, the thickness is around 8 km. As I said, it has a mixed characteristics. Both the names have been given after the scientists who have done their discoveries and the studies. So these are the two boundaries which are also called as transitional layer, or they are also called as discontinuity or interface. This is core mantle interface and this is crust mantle interface. So these are the three boundaries and the two transitional boundaries of our Earth's interior. There is a lot of things to know about Earth's interior. There are continuous changes happening in the crust because of a lot of things. The thickness is getting changed. Our lithosphere is very fragile. Very, very fragile. Because of the continuous changes happening in our Earth's interior. Okay, before I forget, also let me tell you one thing. Crust is also called as mineral skin of the Earth. Because it is the outermost layer. It is called as mineral skin of the Earth. So, because so many changes are continuously happening, because of the forces of nature like wind, water, our thickness of lithosphere is called as very fragile. It's called as very, very fragile. It's a very important give reason. Why thickness of lithosphere is very fragile? Because of the continuous changes and because of the various forces of nature operating. Okay. In fact, there are various theories like theory of continental drift, and there is also a theory of plate tectonic. These theories will help us to know more in detail about why all these changes and how these all changes are happening. They talk about the tectonic plate movement, the lateral movement of the Earth's, of the plates. Everything is in detail in those two theories. So these two theories can help us to know more about the Earth's interior and the changes and the movement happening in the Earth's interior. Okay, thank you so much.